I started about a year ago a woodworking company in Kinsale called MISH. We're just kind of getting off the ground, so nothing too much of a presence yet, but some of the cutting boards and things over here are mine. And my wife and I moved to Ireland about a year and a half ago, and she runs this shop that we have also. That's right. So I kind of specialize in using tech kind of combined with traditional woodworking techniques to make more like functional, and I try to make kind of more fun things than less traditional stuff. And so first, kind of just a little about me as a background. So if I take you all the way back almost or over 20 years ago, in 2003, I was going to university and trying to think of like what I wanted to do. And I really loved art, math, and science, and was kind of thinking about where my life would go in those realms. And I kind of started in mechanical engineering. So my dad's an engineer, and I thought maybe that would be an interesting way. And then I switched majors to industrial design, which is kind of designing things without the engineering side, being a little more design oriented, less function oriented. And then I finally switched majors one more time, and I ended up in 3D animation because I wanted to make movies or video games or something interesting like that. And so, as you may have guessed, I started working in advertising. So I did it almost none of those things, but I always kind of used some of the skills that I picked up along the way, doing advertising, web design, and eventually I was working at an education tech company making software. And then, like I said, woodworking last year as a kind of turning a hobby into a career. So there's something that I realized along the way, looking back in hindsight, is that my passions are not art, math, and science, but I actually really like problem solving. And so that's kind of my big thing that I wanted to talk with you three about today. In particular, kind of problem solving in interesting ways. And I think there are three key components to this. So you have your mind, which is kind of thinking about ideas, and I think really starting from nothing and being able to develop something. So coming up with how you could do something without the blueprints. Then of course you have tools. So there's a big difference between having an idea and realizing that idea. And then, so this could be kind of like a hammer, a paintbrush, a computer, like basically anything. And then there's skills. No. So I don't really believe you need skills in this traditional sense, because I think if you're a good problem solver, you will work around your faults and find a way to achieve your goals, I guess, without having to be the world's best at something, let's say. So is everyone here familiar with Lego bricks? Yeah? Lots of Legos at home, Axel? Awesome. So I used to manage a team of designers, and when I was interviewing people for new positions, I would ask them a question, and that was, how many standard size Lego bricks could you combine, with 6 standard size Lego bricks, how many combinations can you make in connecting them together? So here's kind of 6 standard 2x4 bricks. If you had 2 of them stacked together, or if you put 3 of them together and you kind of moved them, all the pieces around, like how many combinations could you make with that? I thought it was an interesting interview question. So I'm going to come back to that later, but kind of keep it in the back of your mind on how that would work. So kind of moving into the tech and making space, I would say in general, there's kind of 3 main tools that you'll probably find at most kind of maker space today. So that would be 3D printing, laser cutting, and CNC. Of course, this changes, but those are kind of the ones that tend to come up over and over again. Did you say actually you used a 3D printer before? Have you seen one maybe at the library or anything?
No.
No? Okay, this is a 3D printer. It's a pretty kind of entry-level model, let's say. And so I'll kind of quickly go over the difference in some of like what you can achieve or what these tools can help you with or do with you. So 3D printing is probably the most common. It's not too hard to find a 3D printer out in the wild, so it would be the most accessible. And I don't know. Okay, cool. So that's this printer printing. So a 3D printer works by building up, and this is kind of in general terms for most of the things you'll find, but it builds up and adds materials to create something. And so probably most of your entry-level printers are something like this, which uses a filament, which is a line of plastic, and it basically melts it into a form. Of course, there's also resin printers that use light to harden a liquid or epoxy. So these usually work with various forms of plastic. And again, in general, it's actually not 3D, it's 2.5D is what we call it, because you can move front, back, side to side, and at the same time, but you'll do that, then kind of move up a level, and then front, back, side to side, up a level, but you're not really moving in 3 dimensions at one time. With 3D printing, you can reach 6 sides of a cube, so you get the bottom, all 4 sides, and the top. You can print a sphere, basically. Really easy to use. I'd say really hard to design for because you have to completely wrap your head around working in 3D, which isn't a normal concept for us that have been working in 2D most of the time. Very safe, usually limited to a smaller footprint, so this is like about the size of a sheet of paper, let's say, but it can get quite tall. And relatively inexpensive. They are also quiet, but very slow. Again, kind of more your entry-level stuff. And then we get into laser cutting. So this would be, I'd say, maybe your second most accessible one. A lot of maker spaces might have a laser cutter. And they're starting to get, I think, more home-oriented over the last few years and more affordable, but still like a little out of reach for most people. But a laser cutter is this right here. So this works by shooting a beam of light, also known as a laser, and essentially burning material to cut it. So you can see in that video there, it's cutting a piece of wood, then a piece of plywood. So this only moves in 2 dimensions, so just front, back, side to side. And you could only reach 4 sides of a cube, so you can go around it, but you can never get the bottom or the top, usually. It cuts a very thin line, so you're not wasting a lot of material. It's pretty safe, but of course if there's smoke and stuff, you need ventilation, but it's not like out of the realm of something you could have in your home. And you could get a larger working size than the 3D printer, a little more expensive, a lot faster and quiet, but yeah, like I said, kind of requires some ventilation. And then finally, there's CNC milling. So this is also starting to get more accessible, but I'd say it's pretty unlikely that you'd find a CNC outside of a more commercial environment right now. So this is a CNC cutting a larger piece of plywood than we saw in the laser cutter. And basically it works similar to the laser, but by removing material. So you're using a blade essentially, or what's called an end mill, to kind of dig out material, in that case wood. So finally we have our first thing that actually moves in 3 dimensions at the first time, or at the same time. So you could carve a cube, or at least half of a cube, a sphere, at least half of a sphere, like by actually moving in all directions. But you can't reach the bottom, so you're getting 5 sides, all 4 sides and the top. So you can't really do a full sphere, if that makes sense. They are, I would say, difficult to use and design for because it is 3D, but it is flat on one side. So like there is a learning curve there. The hardest part is that you do have you can see here this end mill or the cutter on the end of this has like a large bowl on the end. So you have all these different parameters for different cutters and how they're going to remove the material and react to the material. So that's a bit different. I'd say in general this should be used with caution. Like I have one. It's not like a dangerous machine, but you do have like a really fast blade. You know, if you had like a hand drill that a robot's holding, like you might want to be a little more cautious. Probably not for someone under the age of 10 to use unsupervised. But you can get a really large working size. It's not uncommon to have one 4 by 8 feet, like a sheet of plywood. And you can mill larger things. So the laser cutter, for instance, was doing pretty thin material. This could pretty much do whatever you want it to, including metal. Expensive, is fast, but it is also very loud and very messy because there's a lot of dust and things like that flying around. All right. So this is just kind of a comparison of the three. I'm not going to go through it again, but if you need that information in the future, I can send it to you. All right, and so there's a couple things I'd stress about these three things, which is first, what do they all do, or what do they kind of have in common? They do what you tell them to do. So this is not artificial intelligence. This isn't like, hey, make a smiley face and it'll just do it. Like I have to go to a 3D printer, for instance, and say, you know, move to the left, and it moves to the left, move up, and it moves up. And of course it does much more complex movements than that, but essentially that's what you're doing. You're saying you move a couple bits this way and that way. And if you tell it to move the wrong direction, it will do that. And I've broken plenty of machines and equipment and things for that reason. And the other thing I would say is this is a big difference between creating something and printing something. So you can go online and download files and stuff and just send them into the 3D printer and it'll pop them out, which is great. A lot of people do that, but that's not really creating anything. And that's really the difficult part, I would say, or the most difficult part in my opinion, but also the differentiator that makes you unique. So if you can learn the software good and you have cool ideas in your head and you can draw and sketch and realize those ideas, that's really a key part, I think, about having kind of whatever it might be, a career or anything you want to do in that realm. And I would also say, so my varying background of engineering, not really, animation and software design, like I pull from all the little pieces from that, I guess, when I'm working with this kind of stuff. All right, so that's kind of the equipment, which hopefully was interesting and not the boring part of this presentation. But I did promise that this was painting with robots. That is the title of the thing. So now I'm gonna get really kind of more step-by-step into that.